a cloud. And looks like I'm going to also, let's see, here's on the left side, this stuff, I don't think I need it. For some reason, it's popped up here. So I don't think I want to have it here. I'm not sure how to get rid of it because it wasn't like that before. The rotation. So you can actually enjoy playing with it, but question is how can I actually get rid of this left stuff, because this table is definitely helpful, but not really when we are dealing with the textbook. So let me see. Oh, here it is. Okay. I clicked on these 3 bars and it disappeared. So functions is something that you hear all the time in mathematics class. And here they have various examples of those little functions that you can always work with. And that's what we're actually going to go through another entire semester. So for these functions, what I want is to come to realize that you just plug numbers in and you get the results out. So if, for example, you're looking at the problem, something like here, example 112, and looks like what we need to do is try to plug in the number. So what I can do is on my function g of t, just go ahead and put 27 instead of t and end up with a g of 27. Now you simply plug number in, which is going to be the same as a 27 minus 2. So instead of t, you put 27 in the parentheses. And you also raise this to the power of 1/2. And if you remember, power of 1/2 means it's just a square root. So I end up with extracting a square root from 25. And square root of 25 is nothing else but number 5. It looks like you just replace your unknown with this particular number in the parentheses. Well, sometimes functions are not given in a very nice format, like in the next example here, they give us so-called piecewisely defined function. So there are 2 pieces here. The one piece starts at 1 and goes to the left. And that's when we're using this first notation. And the other piece is going from, so 1 to the left, that's the first piece. And the second piece will be on the right side of 1. So that will be, if I fill this circle because equal sign is possible, and then go to the right. So if they ask me to find f of negative 1/2, all I need to do is figure out that number negative 1/2 is on my first piece because it's less than 1, right? And then I'm going to have to utilize that function, which is a fractional one. And that's exactly what they do in here. So you can see that most important part in these exercises is to plug in the number into correct function. Like in the last part here, they look for the f of 2, and since the 2 is number which is greater than 1, so it's someplace here, number 2, well, then I'm gonna have to put it into the second expression. I don't touch the first because first is for numbers less than 1, but if it's greater than 1 in the parentheses, and 2 is greater than 1, isn't it? Well, then we use that second piece, and whatever comes out, they work out and get number 13 here. So if you can't see anything, the advice is try to restart your computer, because usually that helps. Today I had another student with the exact same question. So try to restart computer, because sometimes it may be corrupted, and that's why you don't see. I hope other students can actually see my screen, and if not, just let me know. So try to restart Zoom, and I hope that way it will help. Usually it does. In fact, whenever you contact the computer support people, all they say is turn it off and on, right? So they just want you to restart computer. Because I'm sharing my screen, and maybe I can reshare it again. I can also try to share this screen again. So I hope that helps. It's pretty much all I can do on my side. So try, if it's still not visible, to restart and see what will come out after that. So they're working with functions, and since these are review sections in the beginning, I will be selective. I will select only exercises that we need for this class, because they might have some more stuff that is just a little extra. Let me try to do exercise number 11 here, because I know that there are some technical issues here on campus, and I hope they will fix it eventually, but again, you never know, right? They might fix it, but it could be too late. So anyway, I'm doing the exercise number 11, and that's how we're going to do problems for this class. At the end of each section, there are exercises. So what I do is I select problems and work them out, and if you find something that works trying, you just tell me which problem you want, because I basically trying to select problems that we need for class, but you might find something that you're interested in. So if my function here in exercise 11 is x minus absolute value of x minus 2. I selected that one because some people might start panicking and wonder what kind of function we're working with here, because it's not very standard absolute value. Well, I want to show you it doesn't really matter what it is. What you need is just to replace your unknown letter x with number 1, since 1 is in the parentheses. So I'm going to go ahead and put 1 instead of x in the places where I see that letter x, and I see it 2 times. So it looks like we're going to have to take inside the absolute values -1. That's what we calculate. And notice that -1 in absolute value becomes positive, isn't it? So we end up with 0 for the answer. So looks like this is the way to go for all of these exercises. You just want to be carefully plugging numbers in, and that's really all it is. So let me try exercise number 14 that deals with function f of letter t. When you say, why would they use letter t instead of x? Well, it actually doesn't matter, but in the physics or other sciences, they like to use time function with respect to the time, and that's probably why they like f of t. So we need to take -6, right, and replace it for my variable letter t. And the question is, where should I replace it? And that's the key idea for this exercise. It looks like here we're dealing with -5 right? That's my first piece here. Then the second piece deals with between +5 and -5 for the second piece. And the third piece deals with +5 going all the way to the right. So I must decide what region this -6 belongs to. So if -6 is in the first region, second, or the last. And looks like -6 is a little bit smaller than -5, isn't it? So it belongs to first expression, which is 3, just like that. Wait, Alex, where do I plug in that letter T? Excuse me. And well, nowhere, because there is no room for it. So one should take it easy, just don't plug it in anywhere, just leave it the way it is, as 3, and that's all. Let me try one more. How about the last one, f of 16? F of 16. Well, I just need to put 16 instead of letter T and see where we have to take that 16 from, right? And looks like our 16 is on the what? First piece. Oh, actually, last piece. Let me do it a little bit more careful. 16 is on the last piece, someplace, and that's where I put that in. Now, I think we had a quiz last time, right? On this type of exercise. Do you remember which problem I asked you for the quiz? I want to do that. It's been a while because we didn't have a class on Mondays. I forgot a little bit, but let me know if you remember which exercise I asked you for a quiz. Was it f of 0? Yeah, thank you for remembering it. So let me do that quiz after this little exercise and we'll move on. So it looks like what we need to do is replace number 16 to the last one, right? Because this is our last piece. So we're gonna extract the square root and say, why is it our last piece? Well, because 16 is bigger than 5, because it's corresponding to this last one. Yeah, and of course you can calculate what square root of 16 is. It's 4, and that's it. The last time we had a quiz and I got very happy because everybody did it right. How about that? When you do it right, I just get so happy and it really makes my day. So thank you for doing it right. And if you didn't send it to me yet, well, send it to me. So it looks like I asked you in exercise 1, so for this function, 3x plus 5, to put 0 instead of x. Okay. So just plug in 0 just like that and see what comes out. And what comes out is just number 5. I have a little bit difficulty to write things down right now because on my office computer, I usually use laptop to do Zoom, but next time I will work out on connecting my laptop directly to the internet so we don't have any more of these unusual things happening. So for the quiz, the answer was 5, and as I said, everybody did it pretty well, correctly, and I guess that's the way to go. So from this section, we just need to plug numbers into the function. So I skip this word problem part because we just here for review, and I'm going to move to the next little section, section 2, that just connects the result. So for exercise number 14, you're talking about the middle part, right? Let me see. I just had a question, so let me go back. So you're working on 14. I'm impressed because this is not that simple looking exercise. So once you found the answer, this is it. You just plugged in the number 16 into your function, and that happened to be into third part. The reason is because 16 was greater than 5. So that's the stage where you're actually comparing. Because once you made a decision that you plug in it in the third part, well, then you go ahead and plug it in. And whatever comes out, you don't really care. You don't plug it in again because you're already done with the exercise. So whatever the answer is, these are the random expressions. So we don't really have to take it that seriously. Let's do number 11. That's a good idea with f of 2, sure, because I just did number 11 with f of 1. So what changes if you're going to replace 2 into your function, which is on the upper right corner? Well, what's going to happen? We're going to have 2 instead of x. So we're going to take 2 instead of x here, then copy again 2, and we have to subtract 2 from it inside the absolute value bars. So something like that. And then we carefully calculate. Whatever comes out will be the answer. Whatever the answer is, one should not really care, because again, numbers are pretty random. So you just can get pretty much anything. So it looks like in my case, this stuff disappeared because it was 2 minus 2. And that way, the answer came out to be just a 2 that used to be there in front. So these are nice problems. I'm glad that you are looking and doing them. And as I said, for homework, whatever we've done in class will be good enough, and looks like you do like 3, 4 exercises, and that's plain. And then you can move on to the next section along with everyone, because I don't expect you to do this on your own, so we can look at it together. So I'm gonna see what's going on in the next section. That again should be something familiar, and that's the whole point of story, just to refresh people's memory. But if you never saw this before, it's a good chance to actually learn it. You just plug in numbers in. So here they are talking about plane of coordinates and how to make pictures on that plane of coordinates. So looks like I can try to see x, y, so-called rectangular plane. And then I'm going to try to put points in, such as, for example, in exercise 6.30. And what's important to realize that those points are so-called ordered pairs x and y. So 3 is for x and 0 is for y. So this point is going to sit right here where 3 is. So that's going to be right here someplace, and that's the position of that point. I think that these points with one of their coordinates equal to 0, very important for us in the future, because they're points on either x or y axis. So what's important to realize is that if one of the coordinates is 0, then you have point that belongs to the axis. Like in this problem, 0 was y coordinate in exercise number 6. So you have point on the x-axis. And if I try exercise number 5, which is the one prior to it, so this is one here. Well, then 0 for x and y will be -2. So I need to go down 2 units someplace here and put a point. Now it's on the y-axis, so -2 is right where we have, again, 0 for x, then point is in y-axis. So I'm sure you're already familiar in producing plots of the points. And I guess this is pretty much all I want here related to it. And the next group of problems is something that I really want to look at, and that's what we're actually going to look at till the rest of semester. Graph various functions. And it turns out that graphing those functions, we try not to use this point plot. You can, but turns out such a exercise, such a graph, as for the exercise number 14, I can write as a y is equal to x squared, and this is a graph of parabola. And if one says, wait a second, now this is not y, it's f of x here. Well, f of x, you can always replace with letter y when you're dealing with function. And actually, we have parabola. I hope you saw this before, so-called U-shaped function, and that's what they actually discuss here, how to work with these parabolas and how to produce their graphs. But for all we care is we see that the graph has x squared in it, so it is a graph of parabola. And example here 1, 2, 2 actually proves that this is parabola by making point plot. So they calculate points and they plot them on this plane, so you can calculate more and more and plot more and more of these points, and one should say, okay, enough, I believe that this is indeed a problem. And that's why in classes that just like business calculus, the graphs, we don't try to do with points. What we do is we just need to remember that the x squared deals with parabola. And actually, here they have some more of these parabolas, like in example 1.24, they give us the parabola, but this is a little bit different. It's given that equation with x squared, but some little extra stuff. The extra stuff is here, plus x and plus 2. So it's going to be also in the shape of parabola, as you can see on figure 1.9, but it happens to go down because of negative x squared. And I guess in the next chapters, we're going to be able to plot these parabolas without doing these little tables of points. But here they actually show you some of interesting techniques. So they set this equation equal to 0, and that's what we're going to do in the future, make it equal to 0. So then we factor it. So they factored, made a product of 2 parentheses. And since the product was equal to 0, then each parenthesis was equal to 0. In other words, first parenthesis, x plus 1, that's the step they skipped here. See, when they solve exercise for you in the textbook, they sometimes skip in steps. So they made first one equal to 0, this one, first factor. And then same with the second factor. So they also, x minus 2, also set equal to 0. Again, because the product of them is 0. And from there, they concluded that x was either negative 1 or x was equal to positive 2. And that's actually what they wrote on the next line down below, solving these 2 little equations. And why is that so important? Well, because they found these points 2 here and point negative 1 that intersect my x-axis. And that's very helpful to make a picture of parabola that goes down, so somehow passes through these 2 points, and that's exactly what we have here produced. So that's, I think, pretty neat, right? So anyways, let us move to the exercises and maybe graph something else, because graphing the parabola is definitely fun. So what other functions we can graph? Well, it turns out that I can try to graph here a function like number 19 exercise. Let me erase this stuff and try number 19. So I think that some students that are on the campus because of no Wi-Fi may have difficulty to log in, right? And that's disappointing. So I guess I'm not going to give you a quiz tonight because I think it's, I guess, not fair, right? Because of technical issues, but I think I'll give you a quiz next time. So no worries. In exercise number 19 here, I can write this equation without parentheses. So what I can do is distribute my letter x over 2x and then also over 5. So this is going to look like y is equal to 2x squared, because you multiply x by 2x, that's how we get 2x squared, and also plus 5, and that would be multiplied by x, so it will be plus 5x, right? So notice that's a parabola function, but now I can use the ideas of previous example to set it equal to 0. So I'm going to end up with either x is 0 or 2x plus 5. So these two factors would both be equal to 0, either x or 2x plus 5. Okay, I'm having issues writing with this mouse. I'm just using the regular mouse attached to my desktop in the office, and that's why I always prefer a laptop to this, because when the touchpad, the mouse goes smoothly, but here it's moving all the way either to the left or to the right. That's why the writing is not as nice. But I hope you can see it. And next time, I promise I will take care of it. I will connect my laptop to the internet. It just takes a while because we have different cables here. So anyway, x is equal to -5 divided by 2, right? Will be one of these solutions. And again, those will be 2 points. My letter y was set equal to 0. So x is 0 when y is equal to 0, right? We just found that x is 0. Or there is another point with coordinates x is 0 when y is equal to -5 over 2. Okay, so we have 2 points here. And what I'm going to do is plot those 2 points on the coordinate plane. So 0, 0 is so-called origin point, right? Intersection of the x and y axis. And there is another point with coordinates 0 and -5 over 2. So this is going to be a little bit to the left from 0, right, on the y-axis. So these 2 points are intersection of my parabola with x-axis, and those are very important points, especially if you took college algebra class. You probably were looking for these points all the time, and they are helpful in order to produce a graph of exercise number 19. So this parabola with equation either in that form or with a form of 2 parentheses multiplied, actually 2 factors. First of them is x, and the second is in the parentheses 2x plus 5. Right? So there's 2 little factors here. So you have the product of them pictured. And again, that's pretty nice. Let me just write y a little bit more carefully. It's kind of ugly looking y, right? Okay, so we've got graph of another function. So the point of this section is to make sure that you start to feel comfortable about graphing various equations, and it just starts. So I don't think you're expected here to graph everything, but we, as I said, going to be graphing throughout entire semester, so you will get used to this little by little. Another important graph is a cubic parabola. And again, usually people remember it and think, Alex, how do I remember that? Well, this is so-called library of functions. So you should know the x squared containing functions are parabolas, and the x cubed containing functions are cubic parabolas. So one end of it goes up and the other end of it goes down, just like that. So that's good to remember. So now what happens if I graph exercise 24, for example? Well, it looks like in exercise number 24, we're going to have a parabola x cubed with a negative sign in front. And we already saw today, right, in examples, that when you attach negative in front of your equation, then the parabola was kind of flipped down, or people say reflected through x. In other words, if I try to graph x2, I'm going to have to reflect the graph somehow here. So along x-axis, we flip the graph. And then in actual 24, where they want to add 1 to this negative x cubed, well, turns out adding 1 to the whole x cubed will bring my graph upwards by 1. So instead of sitting here at the origin, now the graph is going to be moved up by 1. So it's going to like sit at the point positive. And that's another important observation that, again, we usually make in college algebra class, but I will go over all of these ideas with you in the calculus anyways. So adding 1 brings the graph 1 unit up. If you add 2, well, then the graph is going to go 2 units up. Adding 3 will move it up 3 units, and so forth. If you subtract, then the graph will go downwards. And I guess that's the way to think of all of these functions. And that's actually why you really need to have the library of functions. So you don't really have to graph everything from scratch using those points. So I guess this section has not much extra, just keep on graphing, they say, and what I can do is just graph another exercise for you, and maybe that'll be good enough, right? So let me try exercise 25. That's a piecewisely defined function, just like we saw in the previous section, right? We're plugging numbers in exercise 25. I'm going to have to actually think about 2 functions. One of them is x minus 1, and the other is x plus 1. Because there are 2 pieces. One piece is first, x minus 1, and the other piece is second, x plus 1, right? So these 2 pieces is what I'm going to work with. And I just need to graph basically line with equation y is equal to x to be able to produce pictures of these 2 linear functions. And the line with equation y is equal to x is right here. Well, that's another popular little function when x is same as y. Okay. Say when x is 0, y is 0. If x is 1, y is 1. If x is 2, y is 2. But to graph line, we just need 2 planes. We don't need any more. So the graph of y is equal to x. Why is it important? Well, recall the previous story. If you were to subtract 1, then the graph goes down. Right? You subtract, you go down by 1 unit. So it will pass not through the origin, but through -1. And if the graph has 1 added to it, then it's actually going to go upwards. So it's going to pass through positively. So from these two, I will compose the actual function f of x here, the piecewise function, based on those restrictions. The first restriction deals with x coordinates that are to the left from 0 or negative. So from the first function, I just care about everything to the left from 0, is this part. And also I include the point here because there is equal sign. Equal sign means we take. And then I move to the second function where we care about from 1, but on the greater side, to the right. So I need to go upwards. I say, why is it upwards? Well, because the coordinates of these points, x coordinates, are to the right from 0. And notice that we don't have equal sign, and that's why I made the hole on the graph. And now it's time to take those two pink pieces and put them on the same picture. The first piece is line that touches y-axis at point -1. And the second piece is another pink one that sits at +1, right? And keeps going up. And that's my function f of x. Notice I don't call it as y because it's actual function f of x that has to be in a form piecewise function. So I would say that's good enough for this section, and maybe that's enough for today. I don't give you a quiz because of I know some people might have technical difficulties, you can't see it or whatever. So I guess I want you to feel comfortable. So I'll let you go without a quiz today. And next time, on Monday, we will have a quiz. And on Monday, everything will be working because I'll make sure I'll go to this computer people and see right now what they're doing because it's no good that we don't have any Wi-Fi on campus. Well, I guess it's better stay in your place because that's where you have Wi-Fi for sure, right? But that's really inconvenient because I have to run from one building to the other. That's why I was a couple of minutes late. But anyway, so I'm gonna stop this recording for today, and I'm going to let you go and well, just have a great rest of the day and have a good weekend because it's actually what we have coming, right? So for the homework, all you have to do is